Now let's just move on further towards a theorem that is nothing but a theorem number 1, which says that if a transversal intersects two parallel lines, then each pair of alternate interior angles is equal. So let us suppose if I'm just taking a figure for this particular theorem. So this is my figure. So let us suppose if I'm just starting out the proof of this theorem as, let us suppose we are writing the given condition. So we have given the two parallel lines A, B and C, D, such that a transversal PS intersecting AB and CD at Q and R. So this is nothing but a given condition. Now what we have to prove? We have to prove that the alternate interior angles are actually is equal to each other. So as you can see, we have to prove that this angle is equal to this angle. This is nothing but a two proof condition. This is not proved. This is a two proof condition. We have to prove this angle is equal to this angle. We have to prove that. We have to prove this thing that this angle is equal to this angle. So let us suppose if I'm just writing it over here, that what we have to prove. Let us suppose if I'm just taking it as the angle 1, I'm taking it as the angle 2, I'm taking this one as angle 3, I'm taking this one as nothing but angle 4. So we have to prove that angle 1 is equal to the angle 3 and angle 4 is equal to the angle 2. We just have to prove that angle 1 is equal to angle 3 and angle 2 is equal to the angle 4. Now let us suppose if I'm just starting the proof of this particular theorem. So first of all, what can we say about this angle and this angle? Let us suppose if I'm just starting with this particular angle first. Let us suppose if I'm calling this as nothing but the angle 5, I'm calling this as angle 5. Now since PS is a transversal, it is a transversal to AB and CD, it implies that angle 5 is equal to the angle 3. Obviously, we know about this fact that if this is a transversal, then these two angles are equal to each other. Why so? Because they are nothing but called as the corresponding angles. They are nothing but called as the corresponding angles. And furthermore, we can say that the angle 4 is actually nothing but is equal to the angle 1. Angle 4 is actually nothing but angle 5 is actually nothing but is equal to the angle 1. Why so? Let us suppose if I'm writing it over here that angle 5 is actually nothing but is equal to the angle 1, because since if we are talking about the two lines, that is nothing but AB and PS, for AB and PS being the two intersecting lines. So let us suppose if I'm writing it over here, for AB and PS being two intersecting lines, angle 5 and angle 1 form a pair of vertically opposite angle. And since they are vertically opposite angles, so it definitely implies they should be equal to each other, because we know that the vertically opposite angles are equal to each other. So hence, from this first equation, from this two equation, what can we say? From 1 and 2, we can say that angle 5 is equal to the angle 3, which is equal to the angle 1, which implies that angle 1 is equal to the angle 3, which is actually what we wanted to prove. So hence proved the very first part. And in the similar manner means similarly, we can prove that angle 4 is nothing but is equal to the angle 2. So this is nothing but all about our theorem number 1, in which we have proved that if a transversal intersect the two parallel lines, then each pair of alternate interior angles are equal to each other.